Welcome back to another Sunrise 2.x tutorial video. Today's topic of discussion will be on object templates and the scene graph. So let's discuss the three main types of object templates. We have tools, physical objects, and virtual objects. Tools implement the eye-movable interface and can be attached to the end of the robot or the flange of the robot. An example of a tool could be like a gripper that has been mounted on the flange of the robot. Additionally, tools can be safety rated, in which you can add spheres around the tool and additionally add the tool into the safety configurations to be monitored. A physical object also implements the eye-movable interface and can be attached to a frame on the tool. An example of a physical object could be like a workpiece or a screw that can be actively picked up and released by the tool. A virtual object does not implement the eye-movable interface and can be thought of more or less as a virtual coordinate system. One such example of a virtual object could be a screw fastening position, as this would merely be a nominal frame or virtual coordinate system to place the screw at. These object templates are really more thought of as a blueprint for a specific object and not the actual Java object itself. For example, several Java objects can be created during runtime from just one object template. The scene graph, on the other hand, provides a visual representation of how spatial objects are related to one another by means of a tree structure or a parent and child connection. Non-transient objects can be created within the scene graph by means of an object template. However, it is very important to note that the scene graph is only taking a snapshot of the object template. Therefore, any changes created in the object template will not be reflected in the scene graph object after it has been created. This would require you to delete the object out of the scene graph, make your change in the object template, and then re-add the object in the scene graph. During the application runtime, objects defined in the scene graph do not need to be created as they already exist as a non-transient object by default. Scene graph objects just merely need to be found within the application. So let's just start off with a basic example. So let's create a tool template by going to our tool folder, right click, new tool. Here we need to provide the template with a name. This is the blueprint for our new tool called chunk. We can provide some general information. We can give it some load data like mass and inertias. We can also check mark a box that tells the safety system that this tool is to be monitored as a safety related function. One thing that's nice about Sunrise is the ability to add multiple frames to your tool. So up here in this right hand window, we can actually click on our TCP and give it some transformation. So we can say it's 10 in X and 100 in Z. Note that this is the transformation relative to the parent frame meaning the root frame, which is going to be the attachment point to the flange of the robot. Additionally, with the system, we can also add multiple frames. So we could say this is our alternate TCP, and we could also give this alternate TCP a separate transformation. This way, when we move the gripper, we could actually move with respect to a TCP or an alternate TCP with their own relative transformations to the root frame. So for the next example, let's go ahead and create a physical object template. So we can right click on our physical objects and give it a name. I'm going to create a screw that the gripper is going to pick up. So now that we have our template selected, we can provide some general information along with some load data. And just like our tool, we can provide some frames on the screw that we can move with respect to. So I'm going to create one frame called tip, and then I'm going to provide some transformation offset from the parent frame. The parent frame being that it is the root frame. So when the gripper picks up the screw at the root frame, we can now move the tip frame, which is now offset 30 millimeters in the Z direction. Now that we have a basic understanding of both tool templates and physical object templates, let's go ahead and save these templates and then talk about the scene graph. Remember that the scene graph is just a visualization of spatial objects. So here we have our world object, and attached to our world object we have our robot object. And if we go ahead and look at this flange frame on the robot, we can see that there's an attachment point right here, and this says that it's used for the attachment of child objects. To do this, we can go ahead and right click on our robot object and say new object is child. This will allow us to click on our tool template that we created, and this will actually instantiate a shank gripper object. Now this shank gripper object is statically attached at the flange of the robot. So here we have our flange, and at this attachment point, the root of the shank gripper is here. Now remember that this is an actual spatial object at this point, and it is no longer just a template. So if we go to our tool templates, and we were to create a new frame, and then save our tool template, if we go back to our scene graph and click on our shank object, we do not see that change reflected because our scene graph is only taking a snapshot of our templates. So we would actually have to right click on our tool, delete it out of the scene graph, and then re-add a new object as child in which our changes would be reflected. So let's just briefly run through a quick programming example where we can use our physical object template and the tool that we attached to the robot. You'll be able to download this code at the link in the description. So first, we need to inject a new private variable. It's going to be of type iTemplateService, and we'll just call it template service. This will allow us to create new objects from the templates that we created earlier. Additionally, we need to create two more objects, one of type tool from the KukaGeometry.tool package, and we'll just call this one gripper. And additionally, we'll need to create another object of type physical object from the com.kuka.geometry package, and we'll just call this one workpiece. So the next step in this process would be to instantiate both the gripper and the workpiece. Remember that the gripper has already been attached to the robot flange in the scene graph. So all we need to do here in the application is find our shank gripper. So we can say gripper, and the function that we're going to use is going to return a spatial object. So we need to typecast to a tool, and all we need to say is robot and then find object. By doing this, we can now pass in our shank gripper name that we named in the scene graph and end it with a semicolon. So here we'll access our robot object, find the shank object underneath the flange, typecast it to a tool, and set it equal to our gripper. So now the next thing that we need to instantiate is our workpiece. But remember, our workpiece has not been actually added in the scene graph, so it has not been created. We will actually need to use the template service to create an object from our physical object template. So here we can leverage our template service object and say create from template. Here we need to pass in two pieces of information. The template we want to use, which is what we're going to call screw because that's the template we made, and then we need to pass in the class that this template is from. So it's going to be physical object.class. This line of code will then create an object from our screw template and assign it to our workpiece. So now let's actually go ahead and actually use these different objects. So first, let's go ahead and create a target frame from our tutorial frame. So if you remember how to create a frame, we can say object frame, and we'll call it target, and we're just going to access our scene graph.getWorld.findFrame and pass in our tutorial frame from our very first video. So here we have now a frame that we can actually move to. So let's go ahead and just start off with something simple that we've done before. Let's go ahead and move the flange to the target. So we can say robot.getFlange.move, and we're going to move PTP to our target position. And then we're going to also set the joint velocity. We need to make sure we import the PTP motion, and then we'll just say set joint velocity so that we can maintain a safe robot. So this is going to move our flange to this target position. Now let's say we want to move our gripper to our target frame. We can do this by saying gripper.move PTP, list the destination as target, .set joint velocity, and then put in 0.3. So this will actually move the gripper to the target position. But remember, we have two different TCPs, so which one doesn't move? Well, since we did not specify the TCP, it's going to use whatever one is the default motion frame. So I'm going to go to my scene graph, since we're actually using the shunk object from the scene graph in our application, and we're going to check which one is the default motion frame. Now you can change the default motion frame by right-clicking and say, no, I want this as my active default motion frame. So if we have the TCP as our default motion frame, then that's the frame that's going to move to this target position. But note, in real applications, you should actually be always specifying the frame that you want to move with respect to, because if someone comes in and changes the default motion frame, all of your robot motions will change, and this could be a hazard. So instead, let's go ahead now and show an example on how we can actually specify the frame we want to move with respect to. So we can say gripper.findFrame, specify the frame. So let's say we want alternate TCP, and then we can say .move PTP our target frame, and then set our joint velocity. And now in this case, no matter if someone accidentally changes our default motion frame, we'll always be moving with respect to the alternate TCP. Now let's go ahead and attach our screw to our gripper. So what we need to do is we need to say we want our workpiece, and we want to attach to some object frame. Now we can attach this workpiece, or the root frame of the workpiece, to any frame on our gripper. So let's choose the alternate TCP. So we're going to say we want to attach it to gripper.findFrame, and we're going to attach it to our alternate TCP. So at this point in the program, our workpiece is now attached to the alternate TCP on the gripper, and now we can actually just use our workpiece, and we can move our workpiece tip to the target frame. So we can say workpiece.findFrame tip.move PTP to our target frame set joint velocity, and pass in 30%. Now remember that our workpiece is transient, and so at the end of the runtime application, the garbage collector should take care of it, but for good programming practice, we should always detach our workpiece. So here we just say workpiece.detach. Now note that we are not detaching the tool, and that's because that is actually non-transient. That's attached in the scene graph, and if we were to detach our tool inside of the application, then we would run into issues because this would try to detach it from the scene graph. So thank you for listening in, and this will now conclude our tutorial video on object templates and the scene graph.